So today we're going to start looking at probability, and we're not going to do anything super complicated with it today, just really the basics that you probably are already familiar with. Okay, so starting off, just a couple of definitions for you. So when we talk about an event in probability, okay, that is defined as an experiment or process. Okay, so your event is basically the action that's happening. So it could be flipping a coin, it could be pulling a card out of a deck. Okay, so something like that. It's where you're doing some sort of an action to see what happens. Okay, so once we have an event, the sample space, okay, is the list of all possible outcomes. So it's all of the possible outcomes, right, of an event. Okay, so when we talk about flipping a coin, your possible outcomes are heads or tails, so that would be your sample space. Okay, if we talk about rolling a single-sided die, right, your sample space would be getting a 1, a 2, a 3, a 4, a 5, or a 6. So it's just all the things that could very possibly happen. Okay, so a couple more examples here. Flipping a coin twice. So our sample space would be you could get heads twice, you could get heads and then tails, you could get tails and then heads, or you could get tails twice, right? Those are the only possible outcomes. So that is your sample space. Okay. Rolling a single-sided die, we just kind of mentioned this. Your possible outcomes are you could get a 1, a 2, a 3, a 4, a 5, or a 6. So that's your sample space. Okay, choosing two numbers from 1 to 4. Well, you could choose a 1 and then a 2, or a 1 and a 3, or a 1 and a 4. You could choose 2 and 1, 2 and 3, 2 and 4, 3 and 1, 3 and 2, 3 and 4, 4 and 1, 4 and 2, 4 and 3. So that would be your sample space. It's all the possible outcomes. Okay, so everything that we focused on last unit was focusing on sample spaces. Okay, we did tree diagrams. Tree diagrams just list out your entire sample space. Okay, when we were counting an entire sample space. We were saying, how many different ways can you choose a number from 1 to 4 or choose two numbers from 1 to 4, right? And we calculated that to figure out how many different ways it was possible to do that. Okay, so we've done this part before. So now when we talk about probability, probability is the measure of likeliness that a given event will occur. Okay, which you know is how likely something is to happen. All right, so things that you need to know about probability. Probability is measured from 0 to 1. So whole number 0 to whole number 1, right? Where 0 means that it is completely impossible. Okay, and 1 means that it's completely certain. Okay, it's guaranteed to happen. All right, now we can write probabilities as a decimal. So if it's between 0 and 1, we'd write it as a decimal. So you can have a probability of 0.5 or 0.3 or whatever. Okay, you can also write it as a percent. So 0.25, right, would be 25%. So you could write it as a percentage. Okay, or you can write it as a fraction or ratio. Okay, so a 1 in 4 chance that something happens. All right, now, when you find all the different probabilities of a sample space, the sum of all of those must equal 1 or 100%, depending on, kind of what you're looking at. So they have to add up to 1. Okay, so the likelihood of each of these things happening must add up to 1. So for example, in this particular one, it's a pretty simple event. There's a 25% chance that each of these things happens. So 25 plus 25 plus 25 plus 25 adds up to 100%. Okay, so it's always going to add to 100%, or if you're doing it in decimal form, 1. Okay, now notation-wise, the probability of event A occurring, we write as P and then in parentheses A. So P for probability, and then in parentheses you say whatever it is that you're looking at. Okay, and it doesn't always have to be a letter. Sometimes we just write them out in words. right? So it could be the P and then in parentheses, you know, rolling a 5, right? If this was our problem. So you could write P rolling a 5 and do it that way. All right, there are two basic types of probability. There's experimental probability and theoretical probability. All right, and the difference between these two is that experimental probability is based on like actual trials that you've done. Okay, so experimental probability, that would be really anything that has to do with like seeing how like people react to something. So like if you wanted to look at how getting sleep affects your test scores, and you said, well, we studied all these people and we found that getting 8 hours of sleep, people tended to get this test score. So the probability that if you get 8 hours of sleep and you get a good test score, this is the probability. That would be based on experimental probability because it's based on actually trying things and seeing what happened with the people. Okay, versus theoretical probability, right? This one is just based purely on mathematics. Okay, so there's no checking to see what happens. It's just completely about math. So, like flipping a coin, when we say there's a 50-50 chance of flipping heads or tails, that's based purely on math because there's two possible outcomes and it's an even chance of either one, so it's 50-50. Okay, so that's kind of the difference between the two of them. Experimental probability would be taking a coin and flipping it a whole bunch of times and then recording what happens. Theoretical probability is just saying, well, there's one way to get heads out of two possibilities, so it's a 1 in 2 chance. Okay, and then this guy down here, this is just kind of an illustration of this 0 to 1 idea. So a 0 probability means it's impossible, 1 means it's certain. Halfway between that would be an even chance. Down here would be unlikely. So like a 1 in 6 chance is unlikely, and likely a 4 in 5 chance of something happening. That would be considered a likely event. Okay, so that's just kind of the basics of probability. Nothing too super hard or earth-shattering. Okay, so for right now, we are going to look at mostly experimental probability today. Okay, and then we'll look at some theoretical probability for the most part this chapter. But today we're just going to look at some experimental probability. All right, so let's look at this one. So in an unbiased poll, adults were asked, have you ever flown in a commercial airliner? And these are their results. So based on this data, we're going to find the probability that a randomly selected adult has flown on a commercial airline. Okay, so this would be experimental probability because they took a poll, right? And when you take a poll, you are experimenting. You're looking to see what is actual data that people report. Okay, so the probability that you have flown on a commercial airline. So the way that we calculate our probability is we look at it and we look at the number of ways to get a favorable outcome. Okay, so a favorable outcome, aka get what you want, and you divide that by the total number of possible outcomes or your sample space. Okay, and you kind of know that, right? It's the number of ways to get the thing you're looking for divided by the total possible things that could happen. So in this particular case, the thing that we want, our favorable outcome, right, would be that they've flown on an airline. So 710 people said they'd flown on an airline. And we're going to divide that by the total number of people who were asked. So I'm going to have to add those numbers together to figure out the total number of people. That would be 855. Okay, so 855 people, 710, and then I'm just going to grab my calculator. I'm going to throw this into my calculator to figure this out. So 710 divided by 855 is 0.830, right? Or 83.0%. Remember to shift from decimal to percent, you just slide your decimal over twice. Okay, and that's it, so no big deal. Okay, next one. All right, so this one people were surveyed about if they drove an SUV or a sports car, and we have this table here. We're going to look at these tables more in depth later, but the idea is just basically, the males are in this row, the females are in this row, people who are in an SUV are in this column, sports cars in this column, and you got your totals. Okay, so like there were 45 females who drove a sports car. That's how you read that. So we want to know the probability that a female driver drives a sports car. Okay, so when we're looking at this fraction, what we want to compare is our favorable outcome is females who drive a sports car. So females who drive a sports car, there's 45. All right, versus the total number. And this is the part that can throw people off a little bit. So our total number it's saying it's the probability that a female, right? So we're starting with females and then from there talking about people who drove a sports car. So when I look at my total possible outcomes, it's not going to be 240 because that includes the men. Okay, we're specifically saying this has to be a female. So it's going to be 180 that we're taking this out of. Okay, and then 45 divided by 180 is 0.25 or 25%. All right, next one, what's the probability that a person drives an SUV? So a difference here, right? This one was specifically saying females. Now this is saying any person, okay, drives an SUV. So people who drive an SUV, there's 156 of them, right? Compared to all of the total number of people, that's the 240. Throw that into my calculator. 156 divided by 240 is 0.65 or 65%. All right, and then this last one, which is more likely for a man or a woman to drive a sports car? Okay, so we're going to have to kind of compare these two. So we're going to start by taking a look at if it was a man and if it was a woman. Okay, so of the men who drive a sports car, so is it likely for a man to drive a sports car? So men who drive sports cars, there's 39 of them. All right, and we're comparing this to the number of men. We're not comparing this to the total genders, right? We just want to know how likely is it that a man drives a sports car. So it's going to be 39 out of 60, which is 0.65. And then for a woman to drive a sports car, we actually already did this problem, right? So women who drive a sports car, that was 45 compared to the total number of women, 180. And we already calculated that as 0.25. Okay, so 0.65 versus 0.25, right? The closer you are to 1, the more likely it is. So this would be more likely. All right, so that's some experimental probability. And then this last thing here is just determining sample spaces. So this is really just checking, do you have this idea that your sample space has to add up to 1? So all I'm going to do here is that we're saying our sample space is these 3 events. The probability of thing A happening is 0.25. The probability of thing B happening is also 0.25. Probability of thing C happen is 0.5. Okay, so what I want to check is just see, does this all add up to 1? Right, it should add to either 100% or 1. And 0.25 plus 0.25 plus 0.5, that does add to 1. So this is a valid sample space. Okay, so it's a valid sample space because all probabilities add to 1. Okay, now same thing down here. This one, the sample space, there's 4 events, and we're given the probability of these 4 events. So if I add these together, 0.25 plus 0.45, that's 0.7. 0.7 plus 0.35, that's 1.05, and that would be 1.35. Okay, so this is not possible because you're above 100%. You're saying there's 130% total possibilities here. Okay, and that's not a thing. So we'd say this one is not valid, okay, because, right, the probabilities add to more than 1. Okay, so pretty easy to figure out. We're not really looking at we're not looking at how to find these probabilities and how to test if they're valid given the information that you have, right? They're just saying, okay, assume these are the probabilities. Is this actually possible? Okay, So that is the idea of experimental probability. So experimental probability is based off of actual data that's been collected. Okay, later we're going to look at theoretical probability, which is based off of just in theory what could possibly happen.